Okay, hi. So this is week 9, and we are now in the third week of UML diagrams. So till now we've had a look at how to express the structure of your system using class diagrams, and then we also discussed the state diagrams. And I said that that is actually a behavioral diagram where you try to show how each individual each individual object actually reacts to external events. So that is what we have already seen. Now in this week we are going to have a look at how we can make certain more interaction diagrams, and basically interactions too are part of the system's behavior. So till now what we have seen is basically at the level of object, right? This whole concept of showing a state diagram, it is essentially keeping in mind just one particular object. Okay, so you are just trying to focus on how a particular object changes its state during the execution of the system, but we still do not have any kind of broader picture when it comes to the behavior of the system. So for instance, if your system is currently having multiple objects simultaneously, which will be the case most of the time, how do these objects interact with each other, right? It is possible that the so-called event on which we showed a state transition was actually generated by some other objects processing, right? So the object was processing some data, and then it realized that some certain event has occurred. So that object must pass on this information to those objects which are depending on that event for a state transition. But we have not seen all these things, right? We have till now we have only kept our horizons very specific for a particular object. So a sequence diagram, so we will now have a look at a diagram called the sequence diagram, which is a diagram where we actually have multiple objects together, right? So now we are moving slightly towards the system level design, where you are going to show how multiple objects are going to interact with each other. So a sequence diagram can actually be extremely complicated. There are many things that you can show, including conditional flows, but we are not really going into the details of UML to that level. Okay, we are only seeing UML as one prospective way of expressing the design of the system. So the sequence diagram details that we will cover are really basic, and you can of course go on and have a look at the details of sequence diagrams. There is a link in the homework, but what we are going to discuss here is a very simple sequence diagram, where the only thing that you are trying to do is basically show a temporal view. Okay, so when I say temporal view, it means that I am trying to show how certain things happen in my system on the timeline. So you are trying to show what event occurs when. That is the idea. Okay, you are trying to show me the relative ordering between certain events and certain interactions between objects. So, as I said, so a sequence diagram can be extremely detailed. We are not really going into the details of a sequence diagram. We are only going to use the very basic elements of a sequence diagram. By the way, it is possible to include actors. Actors are basically entities which are not a part of your system, but they do interact with your system, right? The typical example is your system's user. Okay, the user is not a part of the system, but he or she is going to interact with the system. Another person who would probably need access to your system could be, let us say, a maintainer. Okay, a person who's going to maintain your system. That person too might require certain inputs from your system. Anyhow, so we'll talk about actors when we discuss the use cases, but the idea is that in a sequence diagram you can mix actors and objects and all those things, but we are only going to discuss the very basic form of a sequence diagram, where what we are going to do is we are going to have only objects. Okay, so we are saying that there are different objects in my system, and I want to show how exactly these objects affect each other, right? So now this affect thing could mean two things, right? It could mean that this effect is in some ways kind of asynchronous as in I tell the other object that something has happened, and then that object has its own way to process that. Or it could be a synchronous thing, synchronous as in I'm as object A, I want certain information or certain task to be done by object B, so I invoke a method on that object, right? So I basically make a function call, something like object b dot func. So these two are the very simple kind of interactions that you will often find in simple projects, and I'm assuming that in your projects too you are going to use something like this. This is very common. So we are only going to discuss that part of the sequence diagram. So basically the overall idea of a sequence diagram is to have vertical and horizontal elements. The vertical elements basically show an object. It could be an actor as well, but we'll keep it restricted to an object. The horizontal elements, they basically show an interaction between different objects, right? So something like this, that when you start creating a sequence diagram, the first thing that you do is that you create these objects, okay? And this is how you show them, right? And you can see that there is a dotted line here and here, okay? These dotted lines are known as lifelines. Okay, so lifelines basically are a way to show that this particular in this particular system, this is the timeline, right? So the top means this is where the system starts executing, and the bottom means that this is where the system's execution ends. Of course, when I say ends, it doesn't really mean that the system goes it has been decommissioned. It basically means that the kind of scenario that I'm trying to show, the kind of behavior that I'm trying to show here, I use this timeline, this dotted line as a lifeline, where we show the different types of interactions that this particular object goes through. Now, in order to actually show an interaction, so a lifeline is like a it's like a assembly line. Okay, it is plain, it doesn't really have anything concrete. Now when you want to actually show an interaction, you add a rectangle to this lifeline called the activation. Okay, this activation thing basically means that for this amount of time during the complete timeline, for this amount of time, this object is active as in something is happening with this object. Okay, it is either receiving a message, or it is sending a message. Something is happening. Okay, it is part of some interaction. This interaction could, by the way, also be self triggered, right? So for example, in some cases we discussed this, right, that in these events, they could also happen because of some timed thing, right? So it is possible that an event is scheduled to happen at a certain point in time, right? So it is a self triggered event kind of a thing. So that also is possible, that if you are trying to show an activation, you can say, you can show that there is a self message. Okay, there is a case where an object is doing something with its own state. So irrespective of what kind of interaction you are trying to show, whenever you want to show an interaction, you have to put an activation on that line. Okay, that dotted line that we just saw. And then we use horizontal elements. These are the arrows basically, and arrow from one rectangle to another rectangle essentially shows an interaction. And these interactions can for our purpose, we'll only consider two types of interactions. A solid arrow is basically a signal. A signal is essentially a way to inform one object, and it's a way to actually information provide information from one object to another object, that some kind of an event has happened. Okay, so it's more of an asynchronous thing. I just told you that something has happened, now you figure out what to do with it. So that is where we use signals. And sometimes we need to have a more synchronous communication. I call up my friend and say, can you please check that you have this or not, I am waiting, right? So your friend goes and checks up whatever was required, and then tells you, yeah, I have it, or I don't have it, right? So it's more like a function call. I called someone, I expected that person to do something for me, and then that person gets back to me. So those things can also be shown in sequence diagram. You basically show a pair of solid and dotted arrows, and you can show them as call and return interaction between objects. So this is a simple example. This is basically the example of a self call. So when I mean what I mean by self call is, it is similar to the alarm condition that I talked about, right? That it is possible that an object actually did something on its own. It could be because, let us say, of an alarm. So this is something that was not really triggered by something external. This is something that is internal to this object. But we are showing it because there may be some significance of this in understanding the system's behavior. This is the example of the call and return thing. You can see that the arrow is slightly different for the call part as compared to the signal part, right? So both are solid arrows, but the arrow types, the arrow heads are slightly different. So and the return type, the arrowhead, the arrow itself is dotted. So this is the simplest form of a sequence diagram. Whenever you want to show interactions between your objects in your project, please try to use this sequence diagram. You can have more than one sequence diagrams, okay? So it doesn't mean that you have to show all the interactions in your system within the same sequence diagram. In fact, it's actually a very poor idea to do that. You would, if you want to highlight certain important facets of the behavior of your project, you should use one or more sequence diagrams. And one more aspect is that in this case there is an understood temporal relationship between these arrows. Whatever you see on top basically happens before whatever you see on the bottom. So that is something which you have to understand, that when you start seeing this sequence diagram, you have to see from top to bottom, because this is exactly how things happen. However, the distances between these arrows, they do not matter, right? So it's not really something that is to scale. So it doesn't mean that if the distance between this and this is more as compared to this and this, it means that the same thing happens in the real world, during the execution. No, that is not the case. It only shows you a relative ordering. It doesn't talk about the actual spacing between these interactions. So one more aspect that we have not yet covered, but it's fairly simple, it's fairly straightforward, but still, it's worth having a knowledge about it. So till now we've discussed stuff at a very detailed level, right? The class diagrams basically provide you a structure of the system, overall system. The state diagrams talk about the interactions. The state diagrams talk about the transitions of the states within the same object, and sequence diagrams is a way to show interactions between different objects. Let us go a step ahead now, okay? A step back, by the way, and try to see the system as a whole. So if you remember, the first thing that I asked you guys to do for your projects is to just collect all your requirements in a nice fashion, right? So that it's clear that what exactly are you trying to do. So a use case is something where that is very similar to a requirement, okay? So in a use case, you express a particular requirement in detail, but the idea is you basically pretend to be the user of the system, right? So instead of being a developer, you try to be a user. You basically say that as a user, I want this, I have this expectation from the system. That is what you try to do, right? So it's like you now pose yourself as the user of the system, and then you're trying to explain how do I expect to interact with this system. Okay, so usually a use case is written, that its details are often defined using some kind of textual mechanism, because you understand that it may not be always easy to explain, because a use case could be very open ended, right? I mean, we are talking about the requirements, the expectations from a system. It's very difficult to come up with any universal graphical language which can cover all possible scenarios, right? So often use cases are actually written in textual format. However, if your use cases are straightforward and everyone involved in the project understands what that particular use case is. So for example, if everyone in your team has a bank account and has done banking related operations, then maybe just writing credit the amount to the account, it actually is very good, right? I mean, it gives you a good amount of information about what is supposed to be done. But yeah, if your team has people who doesn't even know what an account is, what an amount is, what is a credit, what is a debit, then of course you need to give more details. But in case your system stakeholders, they are well aware of the domain, so you don't have to actually explain each and every use case. You can also use something known as a use case diagram. So a use case diagram, it is not really the purpose of a use case diagram to list down all the use cases. That is not really the actual purpose, but that is an implicit gain. The actual usage of use case diagram is to show how your particular system is related to the actors of your environment, of your domain, right? Now I only gave you the example of one actor, the user itself, but for certain systems there can actually be multiple actors, right? So a typical example is that for again, going back to the banking sector, if you are talking about an ATM, and so one of the actors is the actual person who is going to use it. Then there are people who are supposed to fill in the money within the ATM. There could be people who are supposed to check if the software is all right, and or let us say update the software. So there are different types of people who interact with an ATM machine, and they are all actors, by the way. Okay, so the purpose of a use case diagram is to provide this idea that if your system is supposed to cater to multiple use cases, which of these use cases are for which actors. If you want to showcase this in a very compact format, you can use a use case diagram. And use case diagrams again can display very complex scenarios. They can be hierarchical in nature, but for now we are only going to talk about how actors and use cases interact with each other. So actors, I have already told you, they are basically entities which are not a part of the system, but they do interact with it for various reasons, and they need not just be human beings, by the way. Okay, they can be libraries, they can be basically even a software code, a software module which is not a part of your system, but you either depend on it or that actually communicates with your system. That too can act as an actor. So basically we are talking about any entity which is external to the system, but either the system depends on it or that entity depends on the system. So a simple way to show this is something like this. Let us say you have two actors and you have three use cases. You, in a use case diagram, you just link them to different use cases, the use cases which are basically applicable for them. So an example two examples of actors could be customers and administrators. So if you are building a web portal, maybe users and administrators are at least the two kind of actors that will be involved in your system. And let us say an example of use cases could be something like this. The user is going to create a service request, and then maybe the user is going to check upon the status of the service request, whereas the administrator will log in and either approve or reject some kind of a service request. So all these things, these use cases are part of your system, and this box is basically showing the system. And different actors might actually need different use cases. So a use case diagram is used to show this broader picture of your system. So there's like one more interaction diagram that we will discuss, it's just I'm discussing this because many a times people do use it. But keep in mind that activity diagrams, that the last interaction diagram that we are going to discuss, they are not really directly related with any of the other things that we've talked about, right? So an activity diagram is basically another perspective towards the system. You try to say that instead of looking at class as and objects, what if I start looking at my system from the perspective of real world operations? Okay, what operations am my system is going to perform when it starts executing. If I want to show this aspect of my system, I can also use an activity diagram. And by the way, an activity diagram, if you guys have already used a flow chart, you can consider an activity diagram to be a kind of distant cousin of a flow chart. And in fact, if the first time you will probably see an activity diagram, it is quite possible that you might feel that, oh, it is actually a flow chart. But yeah, flow charts are for algorithms at a much they are basically at a much lower level. Activity diagrams are often used for a system wide application, right? And often activity diagrams are also directly associated with use cases. So you can say, for example, that I have 5 use cases in my system, so there are 5 activity diagrams, each explaining from the perspective of real world operations what exactly is this use case going to do. So the boxes in an activity diagram basically are usually activities. These are real world operations, and there are some branching elements and some parallelism indicators, because certain events are they might in the real world they might happen in parallel, and there are certain events who are basically conditional in nature. They may or may not happen. So there are some elements in the activity diagram which can be used to showcase such scenarios, and the lines in an activity diagram, they actually show progression from one activity to another. And depending on your own usage, you can say that basically one activity is filled up is it's made up of even smaller sub activities. There is another term which is used often, and that is known as actions. So you can also say that a particular activity is filled up with different actions, and so you can also show these sub activities or actions within an activity. So that is also possible. It's like a kind of a recursive use of activity diagram. So this is how an activity diagram typically looks like. You have some boxes and you have some lines. There are similar to a state diagram. You also have this starting and ending indicators, which basically say that this is from where you should start reading, and this is where you should end reading. Then there are activities. Activities are basically real world operations, and you can have bifurcations where you basically say this is a condition. If the condition is true, then this operation takes place. If the condition is false, this takes place. You can then also have a merging node kind of a thing where so it's similar to the code that is written right after an if else, for example, right? So you can also merge the conditional flows into one. So this is another example of that. So this is a very simple way to represent activities and the flow. And then let us say I want to split up activity 2 into smaller actions, finer grain actions. That too is possible. And these black filled rectangles, flat rectangles, they are basically used for showing forks and joins. What I mean by fork is that at this point of time, two different activities take on they basically go on in parallel, and then this is more of a merging node again, right? So where these two things they basically finish up, and then from here onwards it's just one single flow. So these are some of the things that you can use in an activity diagram. Please keep in mind that so many interactions, right? So many interaction diagrams that are available to you, they all essentially talk about a different aspect. Okay, they are linked to each other. It's not really that they are completely independent. They are, of course, at the end of the day talking about the same system, but you are not supposed to use all the diagrams. That is what I'm trying to say. Okay, depending on, because at the end of the day the task is to communicate your design to someone else. Now it's up to you, what diagrams do you feel are necessary to do this communication. Okay, um, assuming that you are going for diagrams, you can certainly write text and force all the other stakeholders to read it. But if you are going to use these interaction diagrams, you have to figure out what exactly is the best set of diagrams for you. Okay. You can, for example, this is one way to go about it, especially for your projects, that you can basically start with a use case diagram, provided that your use cases are simple enough. In fact, you can provide both. You can provide detailed descriptions of all your use cases, give them names, and then create a use case diagram just to show how they interact with different actors. Then maybe another thing to do would be to start with the class diagrams and the state diagrams, and then once you have these, it's not a bad idea to use a few sequence diagrams just to show how different interactions take place between the objects. And activity diagrams, you should only use them if you feel that the operations in your system are really more important than the entities, the objects. Okay, if you feel that is the case, then and only then should you go for using activity diagrams. Okay, so there is some homework, have a look at it. Thank you, bye.